Howdy. Hope everybody's having a good night. Um, I've got one of these Allison transmission modules here. And, I gotta tell you, I hate these things. I had quite the battle with these. Uh, they're very troublesome module, and they're extremely prone to failure. And unfortunately, they're mostly in work trucks, so uh, they take a lot of abuse. And currently, these guys are on back order. You can't get them anywhere. Like the dealer, they can't supply them. And used ones where people claim are good are selling for I think like $4,000 or $5,000. And it's like I said, because they're work trucks. People feel like they're forced to have to buy that to get the work truck back on the road. But man, I spent I don't know a good month doing nothing but these. I had a slew of them come in, and man, I spent so much time and money trying to get these guys repaired, and unfortunately, they just it's not much you can do with them. So I have this one here. I stopped taking them just because they're such a pain, but I do have this one here that I wanted to look at for a friend, and I have a little tester that I made here for him when I was trying to get them all sorted out. So I'm gonna go ahead and we're gonna hook this up and see what we can do here. I'm just hooking up the data lines here. I have all my power and everything that will come through here. Now, typically when it's good, when it's working, we'll see this valve solenoid. This is the pressure control valve 1 solenoid. We'll see this one come on. And we'll know that it's good based on that. Let me make sure my switch is on. Okay. So right now the module is actually functioning properly. And the typical problem with these is when you run your truck for a while, it will be fine, and then all of a sudden it just cuts out. It goes dead, and you can't communicate with it, or it just has all kind of crazy codes. And it's pretty much the same with all of them. They heat up, they stop working. And when I first started doing these, I had so much hope for them because there's so much to go wrong in here. You got this driver IC that I was hoping was the main culprit. It's got a lot of little MOSFETs here, small MOSFETs. Got some MOSFETs here for the power filtering. It's got some power management stuff over here, and the data, the communication. Kind of hoping that maybe something in there was overheating and killing them. And you have the bonded wire. And anybody that knows anything about bonded wire knows that bonded wires like to come loose. I really don't know why the automotive industry keeps building crap with these bonded wires like this, because they just don't hold up. Most prevalent in ABS modules. Almost all ABS module failures is because the bonded wire didn't hold; it just come loose. But anyway, so unfortunately, it's never none of them things that fail. But let's log into our scanner here, and let's just do some quick checking on it. Let me remember. It's been a while since I've done one, so you have to give me a second here. So my lights I got here, these are just for the different solenoid valves. These here are for the range sensor, and this is some other kind of sensor for the transmission. Just some basic switches here. So, and then I also have the temperature sensor there for the transmission fluid. I don't think we're gonna need the oscilloscope on here, but we can. If we do need any measurements, we can take some. Okay, so there's our output. Let me try just checking some old stuff there. Let me put that up here in case we do want to see it. All right, so I don't remember what year this particular one is. So let's just do this. go try light duty. We can just go into the Chevy and should be able to just go into the Silverado. I'm not sure if it really matters too much. This a lot of stuff here. I think I went into the wrong thing actually, but that's okay. Let's see if we can't get into it from this. So I think I accidentally went into the 6.0. It's supposed to be a 6.6. So let me actually go back. Because I don't think the 6.0 is going to work. It's a lot different. Maybe we can go in here. No, maybe not. Let's go into GMC. Nope. Let's try GMC truck. Let's do the Sierra. Let's see if we see the 6.6. Okay, so here's the 6.6. So let's go into, I think either one of these should be fine. We'll just go in with this. And I don't think the weight really matters too much for what I need to do. Or the other options, I don't think they really matter. But here we can see, was it like 16? I thought that was a little bit higher usually. I thought that was about 20 on before, and this one's not on. Oh, there it is. Still probe it good. So I researched these modules a lot. Like I tore them down. Like you'll see, I have this one here. This was my my tested one, so I could find out where everything goes, and just kind of reverse engineer it a little bit. And it was nice to learn so much about it. If multiple things failed on them, so much in there, could fail that it can be fixed. Unfortunately, most of the time, the failures that they do have, it's not much you can do with it. Okay, so here we go. Now we are in the transmission control module, and I don't remember what codes that I'm supposed to see from this. Okay, so I might have this wrong. There we go. Okay, so let's just check the current code here. So TCM power input signal. So this ignition is good. Previous one has failed. So, we have basically it's saying it's got low power or it lost power, which, when I first used to see that code, I had a lot of ideas of what I thought it could be losing power. Besides it being external, like a, terminal breaking or something like that. I thought maybe the TVS or maybe the power supply, or maybe even there's a MOSFET here, for the filtering of the power. They have them running through there from the ignition, and unfortunately that's not it. But let's see, let's erase this. So right now we will have, man, I got my power kind of high here, don't I? Let me turn that down. Didn't know I had it so high. So now I don't think we're going to have any codes now. Okay. So far everything is normal. This is actually perfectly working module right now. There is no problems at all. And we can go here and we can activate anything you want to activate. So let's see, let's do our TCC solenoid control. And there we go. I turned it on. We see it light up. Okay, let me turn that off. So that solenoid control work is good. We have our, I can't remember if this one does anything. Let me see. I know this one does. And well, we lost power there. So now we've lost power. So something had overheated. I didn't notice the current consumption change, so it doesn't look like a typical short or anything like that. And the first sign that something happened was this light right here cut off. And it's still off. And we can see here the processor is getting a little bit warm. We've got our power management over here. A little diode. Now, I don't know what they're running at. That might just be on normal temperature. They don't feel hot. I have to wait till this thing starts up. So 35C, that's not too bad. That's okay. I'm not sure why it cut off. Let's try to reset it and see if we can't get it to come back. And there we go. We see it come back. Let's see, we're still. So we've come down a little bit from 35 to 31, and we cut off. Let's see if we go back up. Nope. All right, so our TVS is still good. Now we can see that our so this thing I'm probing right now is I guess it's a P-channel MOSFET, and basically the power comes in to these guys, and they actually power most of the module. I guess it's like a filter. I guess they're using them as kind of like a filter. It's just a little bit different than what I was used to seeing, but anyway, they only come on when this guy is doing good, and he's not doing good. He's not active right now. So there we go. And you see, I push on it, it come on. So we know what the problem is now. If you work in this type of stuff or you work with BGA, you know that you see that our BGA chip is loose, right? So our fix is to remove that, reball it, and replace it. Which, you know, normally it's not too bad. It's doable. I mean, that is a doable thing. And this one's pretty consistent too. Normally it's a doable thing. But now let's take a look at this guy with him unhooked. So typically they don't fail that fast. Typically they have to heat up before they fail that bad. But anyway, so right now we have this plastic case with this massive heat shield here to, you know, let the heat out. You see it's designed to let the heat out, right? It's pretty thick too. I think I actually have one. I have one here somewhere. Well, here's the one where the board is missing. But anyway, it's really thick. You see there how thick it is. And board is glued to that. And we have these aluminum bonded wires here. You're screwed in, and there's no way to separate the plastic from the heat shrink. So you have to, you know, you have to destroy this case to get the board off. Right? To get it like this, you have to destroy the case. You have to destroy the bonding wire to get this board off. Now you could say, well, let's try to reball it with it in the case. Trust me, I've tried everything. So you try to reball it in the case, right? And you're thinking, you know, I think I can work with all this and it will be fine. You know, I'll just try to heat this particular area. I can kind of see everything here. As long as, you know, I watch it, keep an eye, I should be able to reball it and then switch to, you know, like leaded solder when it's done, so I don't have to heat it up as much when I actually go to set it back, right? But here's another thing. So not just the bonding wire that we have to fight with, not just the heat sink and the case being inseparable we have to fight with. We also have to fight with this, which they're removed from this board. But here is another BGA flash chip with quite a bit of balls, and then there is a little BGA, another little BGA chip. I'm assuming it's just another little small flash or another small EEPROM, something like that. And then we have all these little surface mounts here for the, you know, resistors and capacitors for the flash, and, you know, the different IOs from the MPC here all coming through here. And they have this heavy conformal coating. And if you work on ECUs a lot, you're used to this conformal coating. And I don't know if you know this particular one. This is this bluish one. And I used to see this a lot on Chrysler skim modules. So most people may not know that one, even if you work on ECUs. You might not be familiar with that, but they use this in there too. And this crap, when it gets hot, it starts bubbling. And it loves to just lift all of this stuff off, right? So you're getting hot, you're getting this whole area hot enough, this top side, you're getting this top side hot enough to remove this chip. You're overheating this side, which is sitting inside of the heat shrink, the heat shield here, sitting inside of that, right? So this is extremely hot, or, you know, it's going to be very hot, whatever you have your heater set at for the bottom. That's the temperature. So, you know, it's extremely hot. And then you're having your top heater trying to heat this to remove this. You end up, you know, destroying these two BGAs. They're going to bleed together. They're going to short. And half the time you end up, heating these up so much where they get the little balls. I don't know if you've seen it, circuit boards where you heat them too much, the solder just kind of balls up. And since they're such small packages, the little resistors, I mean, I don't know how well my camera quality, not very good, but the little tiny resistors, you can see they're just really packed together, so the little balls just short them out. And the conformal coating just causes it all to bubble away, lift them up randomly. Um, but the main problem still is the BGA. That's the biggest one. So it's damn near impossible to do it still in the case because of this. If this wasn't here, like this was somewhere up here, they made it just work up here somewhere, then it wouldn't be a problem. If this was all glued to the heat shrink, and then the little passives were over here somewhere, they just made it just a little bit bigger. I mean, because I don't know if you've ever seen where this sits in the truck, but they have so much room there. What the hell? What the hell did they do this? Pack it like this, and this board is it must have so many layers in there. But it's pretty thick. But it's amazing. It was amazing to me when I cut into this and dug this guy out to find that there. I was really surprised. I thought that this was all that I had to work with, and then actually when I saw that, that was just kind of the nail in the coffin there, because I don't mind doing BGA work, and doing this BGA and doing these at the same time, I wouldn't care too much because it's a good repair and people need them. But then just everything together, the wires, you have to have a bonding machine. I tried to do some where I would actually just try to convert these to normal wire, and it's just not efficient. It just doesn't work. It doesn't give a good product, and it's not going to last, right? And just dealing with all of these other things, dealing with it all together, I just kind of started walking away from these, unfortunately. And I don't think there's much that anybody will be able to do without a good system set up. Like I have a really expensive DJ machine with a camera and everything for aligning it and getting it's almost all automatic. It's pretty nice. So I wouldn't have minded if it was just this. And I even experimented with just trying to get it like halfway like this, but it wrecks this area so much. And these stupid things, you look at them funny and they start coming off. And I don't know, it's just a mess. So that's about all there is to it. It's this chip every time. I mean, it's either this one or the flash one's underneath every single time. Uh, I ran into a couple that I was able to repair. I don't know if I just got lucky when I reballed them because like I said, I had a ton of them come in. So I would always still try if the customer wanted me to. Because if you try and fail, the module's going to be completely dead. It's not going to be like it is right now where it just fails when it gets hot. It's going to just always be dead. But I did have a couple go okay. And I did run into one where this chip actually was bad. And was able to replace this one, which was very difficult to find, to source the actual chip for this, because it's a mass chip. I think it's not even mass. I think it's true custom. I think it was made truly for them. I don't think there's any other like open market compatible chips for this. And at least if there was, I never could find one. But I did source some of these original chips, uh, but it was so rare. So I mean, it's not worth getting these in and spending all the time on them. Just once in a blue moon being able to fix them. You just have a lot of unhappy customers, and you have a lot of wasted time.